Hi, these are your TAs, Ankit and Sehaj, and this is the ball toss lab tutorial. In case you're confused where the power button is, it's here, on the CPU unit. You press this button for the power button. I won't press it because it's on right now.
Open Data Studio. Then hit Create Experiment. Once you've done that, you'll see the console. Click on the first port and enter Motion Sensor.
First, take the motion sensor and plug it into the sensor box. Make sure the yellow is in the first position and the black is in the second. Place it wherever's best to run your experiment. Then click on Graph as highlighted here. As you double click, select the graph you want. For this lab, we'll want all of these graphs, so we'll click on all of them.
Close your experiment setup window, and in order to tile the graphs, hit Window, Tile.
Start the experiment. You throw the ball up to create a vertical column so it can record your position, velocity, and acceleration.
You can't do the analysis if your graphs are all misaligned. So what you have to do is make sure that the y-axes of all of these graphs line up. So to do that, you should just move your cursor to the x-axis. Cursor at the x-axis. Drag it to the left so that the y-axis lines up with 0, since there's no negative time.
It should snap into place when you've done it correctly. To start your analysis, you need to highlight the free fall points of every graph. That's the little hills for the position graph and the spikes for the velocity graph. To highlight, you want to drag a box around the points that match up with this free fall portion, as seen here. Once you do that, you want to find the best equation, or the linear, or the fit, for each of these hills. To do so, you want to pick the quadratic fit because it best represents a parabolic function for position. You do the same for velocity, except for velocity, it matches a linear fit. So you'll select those points, but this time, in the fit section, you're going to pick the linear fit option. When you press fit, what it does is it finds the equation that best matches the graph. The coefficients that are generated match the polynomial equation for a quadratic in the first box. A, x squared plus b, x plus c is the equation it's trying to match.
The coefficient of the quadratic fit should represent half g, since you'll remember that the kinematic equation is y equals b0t plus 1 half gt squared. And you'll notice here that in ours, it's very close. It's negative 4.73, and half g is negative 4.9.
What happens if you messed up, Aaron? Well, have no fear. You can just delete runs and redo them. To delete it, you go to the experiment section and select the delete last run option. It'll give you a confirmation box, and you confirm.
The lab. So now you can just clean up and eventually ask Mrs. Romer for the write-up instructions for the lab. And remember, the safety rules are extremely important.